let's talk about trust material and trust relationships, okay? So far, we've understood this idea that if you're running in the context of a user who is a local administrator, as far as another system is concerned, you can do things, right? Well, now we're going to talk about how that works. And we're going to talk about access tokens, which is the heart of this whole thing. We're going to talk about credentials, password hashes, and Kerberos tickets. When you're on a Windows system and you try to interact with another Windows system, Windows will try to automatically authenticate to that system on your behalf and tell that system who you are. That's single sign-on. And it's in the mechanism in Windows that allows you to browse file shares without being prompted every single time you want to copy a file or go into a folder. It's the mechanism that allows us to share printers. It's the mechanism that allows us to transparently authenticate to a proxy from a system joined to the domain. So single sign-on has a lot of convenience benefits. The heart of single sign-on is the access token. Access tokens are managed by the LSAS process in Windows, and LSAS is the security broker on a Windows system. They're created after logon. Access tokens are associated with each process, and each thread in a process may have a different access token from the process. Access tokens contain information about what rights the user the token represents have on the current system. And it also contains references to that user's credentials in many different forms. And this reference to these credentials is what enables single sign-on in a Windows environment. Now, if you have a beacon running in an administrator context, you can take advantage of token stealing to impersonate the rights of another process that's running on a system, okay? Here's how you do that. Use PS to list processes. And if you want to take on the rights of another user, use steal token, that process ID. And you will now be running with that access token. And if you try to interact with a remote resource, Windows will use the information in that token to negotiate and authenticate with the remote system. And if that token happens to have information that is seen as a local administrator on that other system, then you're in effect a local admin and you can do things. Now to find out which token you have, type getUID to find out your user context. And if you want to drop a token, just do rev to self and that will drop the token for you. Let's go ahead and do our first trust relationship demo. For these demos, I'm going to work from the system level beacon on the Climber system. And let's just be clear that our this beacon has no permissions anywhere because it's running as system. Okay? Can't do anything to the file server, can't do anything to the domain controller. So if we want to take on some rights, one way to do so is steal them from another process. So let's do a PS, and we can see there's processes running as JSmith, go figure. And there's also a process running as administrator. Why MS Paint? I have no idea. Either way. Let's go ahead and steal a token from process 2944. That's the Playland administrator account. Now, let's see if we have rights on the domain controller. We do. Let's see if we have rights on the file server. Big surprise, we do. Cool. And if we do a getUID, we can see that we are the administrator for the Playland domain. And if we want to, we can drop that token with rev to self. And now we're a nobody. We don't have any special rights. Okay? So that's an example of token stealing. Now, let's talk about credentials. If you're in a privileged context, you can use make token in beacon to create an access token from credentials. Just do make token, domain /user, and the password. That's it, okay? If you want to interact with a local account on a remote system, do make token period instead of domain /user and the password. Again, simple as that. Now the problem with make token is much like steal token is it requires you to be in an administrator context before you can actually do anything with that token. So what happens if you're in an unprivileged context and you want to create a trust with a system? Well, you have a few options. One, you can use spawn as to kick off a process as that user. That would be my preferred method, okay? But you can also just use net use on the command line to establish a trust relationship with that system. So net use /host $C$, /user : domain user password. Okay, let's take a look at using credentials to make a token. Previously, we were able to collect the domain administrator's password using Mimikatz, right? It's waza1234 ! So let's go ahead and try to make a token with those credentials. Let's just do playland /administrator and then paste in the password, and there we go. Now when you use make token, what it does is it creates a copy of your existing token and modifies the single sign-on information to pass the credentials we specify. This is actually native Windows calls to do this. It's nothing too special. But that's why you're seeing that we're impersonating NT Authority system. Because on the local system, we're still the same person. It's just when we interact with the target, we're somebody else. So if we do a dir on the file server, you can see that we are who we claim to be. Or let's do invoke command -computer name DC, and we'll just do a who am I over winrm, and you see playland administrator. So the token we made with make token works. I'm going to go ahead and drop the token, so we're back to being nobody special. What about pass the hash? This is a good one. So Beacon uses Mimikatz to pass the hash. The syntax is pth domain /user NTLM hash. You can do a local account as well, just specify the computer name or a period instead of the domain name. Okay? Now you may be asking, what does this do? How does it work? Well, Mimikatz starts up a process with an access token whose single sign-on information is populated with the username, domain, and password hash that you provide. Cobalt Strike's Beacon then automatically steals a token from that process and shuts it down. So in effect, what you end up with is a token in your beacon that will pass that password hash when it tries to authenticate to a resource on the current Windows network.